Okay, today I'm going to be teaching differentiation. This is higher level mathematics for high schoolers, secondary schoolers, like where I stay. I'm just going to be teaching the basics, so this is part 1. First of all, differentiation. Differentiation, I don't like definitions, so I'm just gonna skip to the main part. The main part we're all waiting for. The solvings. I don't keep differentiation definitions in my head, but I know everything about it. So first of all, what are we gonna do? Let me give an example. Let's say y is equals to x. So the x is equals to a function of x. What do I mean by that? I mean that y is a function of x. So either we write y is equals to s, or f is equals to fx is equals to x. When we say fx is equals to x, the differential value of it, we add the prime, that is the f prime x is equals to x. That's just my own method. So from what we've talked about here, we have rules to differentiation. First of all, I'm just going to talk about basic differentiation rules before we go to other ones. Sorry, I like keeping ruling lines and my lines in the straight, but doesn't matter. Okay, first of all, y, let's say y is equals to x squared. There's a law for that, for this kind of expression, apart from the first principle, which I will come to later. But let me put down this laws first before we go to the first principle, because that one's more complicated. So first of all, if you have y is the main variable representing the function of x, and let's say there's a constant. Let's use a as our constant, and then what x is by its raised to power, let's say n as the value it's raised to power 2. Then our dy dx, that is the differential function, or the function of x, of in this case is going to be that a times the n with still the same x, with the n raised to power the n and minus 1. In other words, we mean a n x n minus 1. It's a law. It's a law in differentiation. That's number 1 law. Number 2, if y is equals to if y is equals to a raised to power x, here the constant is raised to power the variable, that's the function, the x in question that we're going to find the function of. So we're going to do this in with respect to x. In that case, we're going to end up with a times ln a. Yes, that's going to be ax ln a. That's what we're going to do. That's the differential value. That's the dy, the x of it. It's going to give us this. Then Number 3, let's say we have y is equals to ln a. Therefore, our y, if y dot x, oh, I didn't know I wasn't recording all the while I solved that. So from here, okay, wherever I stopped, y is equals to a raised to the power x. Then we're going to have dy dx is going to give us a raised to the power x dot ln a. This is a rule. You have to take note of all these rules. Y is equals to ln a. So I'm showing you here that you can change this x to anything. Let's say I use a for example. So dy dA goes to 1 over a. I made a mistake here, that's why I just changed everything to a. It doesn't really matter though. So here when we have sine x, then our dy dx version of it is going to be cos x. Similarly, if we have y is equals to sine ax, that is, there's a constant here before the x, then we're going to be having a cos ax. This is going to come out, but it's still going to repeat itself as a cos ax. So now we're going to have y is equals to cos x. So our dy dx version is going to be cos sine, minus sine x. Therefore, similarly, we'll have, if we're having y cos ax, then our dy dx version of it is going to be minus sine a x. The a is going to come before everything like before. So for sixth law, y is equals to log ax. So we're gonna have dy x of it is gonna give us 1 over x ln a. That's just the rule. And 7, if we have y equating to log 10 x, then the y to x is going to give us 1 over x log 10. And then exponential function, let's say y is equals to ex. Then exponential function, it means something, so it's not just a variable or a constant. So when I have y equals to itself, ex, like that, and that's how it goes. So y, if y is equals to a, the y dx, that is, a is a constant. Given that a is a constant, if y is going to a, then the y dx is going, why I said dx, because a is a constant. And they said find dy dx, which means there's an invisible x that doesn't exist in this particular equation. So dy dx is just telling us that this a is dead, is gone, man. So the constant is gone, it just gives us 0. And if y is equals to only x, then dy dx is going to give us 1. That's the rules for differentiation I have for you for now. So in our next video, we'll talk about first principle, and then we enter solving questions and equations.